Spruce Labs booth. All right, next up, this is always a fun one, so I'm really looking forward to it. We're going to get ready for the second installment of Houses from Heck with Chad Robinson and Josh Kerber. Guys, I hope I don't botch this, but what the title says is 140 CFM, 5 CFM, more is better, right? And low flow RRNC. All right, so go ahead and click on the next session and keep taking notes. Okay, are you ready? I'm going to turn it over to you.
Yeah, we're ready to go. You ready to go, Josh?
I think so.
Gentlemen, give it a minute or two because it's 3:42 and we'll want to make sure everyone gets to you and settles in for the last 15 minutes, okay?
Yeah,
we've got plenty of things to fill 2 minutes.
All right, well, I'll let you go. Thank you very much.
Josh, we've got 2 minutes. Could you just kind of turn around and take those signs off the wall?
Nope. Winners. This room is full of winners.
All right.
Unfortunately, for some reason, Josh cheers for the other OSU.
Oh.
Yeah. See, the actual OSU is Oklahoma State, and then there's the other OSU.
Well, as soon as you Cowboys ever win a title in your lifetime, then we can talk.
We're talking about football titles here, I'm assuming, since we have more actual national championships than the other OSU does.
Yeah.
Football's the only college sport that really matters, man.
Well, I mean,
kind
of true.
What do you got? You got some rodeo titles down there or what?
I suspect. And there's probably some golf and bowling in there as well.
There you go. Trap shooting?
Where I'm at, so, you know.
Possibly ping pong.
Ping pong.
Nice. Nice.
I think everybody's moved over, guys.
All right.
Guys, have fun.
I will share my screen here. And Josh, are you done with your slides?
Yep, just in the nick of time.
Good. It's about like it normally goes then.
Right. Except yesterday I was done a day ahead of time. So here we go.
All right. So yesterday we ended up the day with Josh talking about a radon system where the installer put in a fan that was too big for what was needed, and it was backdrafting a wood stove. It was backdrafting to the point that they couldn't even get the wood stove to light because it couldn't get enough air to get the fire going. So I've got a similar kind of situation where I'm going to light up my little pointer here, where we had a basement. It's a fairly small basement, about 20 feet this way and 40 feet this way, but there was a huge crawl space off to the side and a big garage up to the top of this screen here. And it was important for us to minimize the amount of airflow coming out of the basement part of the system so that we could put the rest of that airflow, minimize the amount of the fan size that we had to use, because we had to have a certain amount of air going over to the crawl space part. So we had a suction point here, and then we had a test holes for our pressure field extension where you see the T1, 2, 3, and 4. And now we're just going to talk about a lot of numbers here. And I tried to make this so that we can look at the numbers that I'm talking about. So without doing any sealing at all, no optimization whatsoever of this system, I just drilled a hole. And honestly, I didn't even have to dig a suction pit because the soil had kind of settled away from the bottom of the slab. And also, just so you know, we deal almost exclusively in tight clay soils. And so we shouldn't have a lot of airflow through any of our systems. But
so if you shouldn't have a lot of airflow, why do you have a lot of airflow?
Yeah, so I didn't do any sealing on this. And in order to reach this T3 over here, I had to move 140 CFM at 3.4 inches of static pressure to get 2.4 pascals negative at T3.
And what's the wattage on that?
It's probably 120 to 150 watts. I didn't measure that exactly, but just based on what I know about fans in that particular situation, that would have been about what it was, 120 to 150 watts. So I was like, okay, now what if this basement just had a storage room, and I was able to caulk 10 feet on either side of the suction point? That would be this line, 20 feet of caulking, 10 feet either side. That lowers the flow rate down to 12 CFM, and 1 inch of static pressure is what we need to create that 12 CFM. And we still have 2 pascals of negative pressure at T3. So what I did is I sealed this wall. Oh, go ahead, Josh.
So I'm clear. You did 20 feet of caulking, 10 feet on each side, and then you dial down a fan, or you choke the airflow in the system down to just get your wiggle of 2 pascals at T3, correct?
That is exactly right. So right here where my pointer is, I caulked the wall to floor joint right there. Now the wall to floor joint was about, I mean, I might have been able to drop a dime into it, no bigger than that. So it wasn't huge, but not tiny. But we can move apparently a pretty significant amount of air through that little crack. But this was an open basement, so I could caulk everything. And I just put 4.3 inches of static pressure on there just to see how much air I could move after everything had been caulked. And I was moving 25 CFM. But look at T3 now. I've got negative 41 pascals. And this probably represents 100 to 120 watt radon fan right here. But do we need that? Do we need negative 40 pascals, Josh?
No, you need like -3 in your world.
If I can get a wiggle at the farthest point in my world, I'm happy, honestly. So now I go down to 2 inches of static pressure. This is kind of mimicking a mid-range radon fan. I've still got 22 pascals negative. I mimic a low wattage fan, like the smallest radon fans that aren't adjustable. And I've still got 12 pascals negative. So I'm like, okay, well, what if I just cut that in half? I've still got 6.5 pascals negative. So I'm like, okay, what does it take to get 2.5 pascals negative? And I turn it down until I've only got 1,500 or 15 hundredths of an inch of static pressure. You can barely see this on a YouTube manometer. So if I dialed a fan down to this level, you're not even going to be able to tell that the fan is on because it's such a small amount of static pressure. 5 CFM and 2.5 pascals negative. That's all I need to fix this basement. All of the rest of the air from my radon fan can go to, or all the rest of the capacity of the radon fan can go to the crawl space. So I can put a damper on this part of the radon, the basement part of the radon system, and send however much capacity I need to the crawl space now, and I can fix it all. The whole big 2,000 square foot crawl space plus the basement with a mid-range fan that's using 45-ish watts. So I go from needing 150 watts and pulling 140 CFM out of the house to only needing 5 CFM coming out of the basement. And I can use a total, including the crawl space, a total of 45-ish watts for the radon fan and no air coming out of the house.
And how long did this take you to do this caulking to take these numbers?
Oh, the caulking, 10 or 15 minutes at the most.
10 to 15, yeah. So like
and that's probably mostly because I had to move a bunch of stuff around.
But you actually move stuff around to get behind it. That's good because
yeah, I didn't caulk up to the cardboard box and then go to the other side of the cardboard box and start again.
Okay, good, because we've seen that.
We have.
All right, so that's fascinating. So in your world, though, just when you typically core through your floor, you're hitting clay, tornadoes, and Dorothy in almost every house. But because this slab had settled, you had a big air gap between.
That's correct.
You use the caulking to seal the dime-sized Plinko crack at the floor wall joint.
Right.
So you basically just put an airtight lid on this whole thing. You didn't even have to drill a suction point because you had ample air available to you.
I didn't have to dig a suction pit.
Yeah, that's what I meant.
Right.
That's awesome.
So this is a fairly uncommon basement for us because we typically don't have that much settlement. So typically it takes us an inch to an inch and a half of static pressure to get this far across the basement. So in my world, we even though we work exclusively in tight soils, we never use high pressure fans.
I was going to ask that. Do you carry, you obviously have to have high pressure fans on your truck, but how often do you use them?
We do not carry a high pressure fan on our truck at all.
Fascinating.
So the last time I used a high pressure fan was on a commercial job. So we don't use them on residential jobs at all. Occasionally we have to put in a second suction point, but that's all.
But what better way to get your extension rather than overpowering one suction point? Just
Absolutely.
add a second. All right.
Exactly.
Okay.
Well, I'm going to stop screen sharing and turn it over to you. I know that you've had some similar experiences. Let's see what you've got. How can you compare to this?
Well, it's actually similar, but it's new construction here. So we're going to talk a little bit about fan sizing for new construction and operating costs of fans. Come on, arrows, let's go. We don't got time. Here we go. All right, so suburban Minneapolis here. This home was built. It's a one-story, 2020 build. New construction, radon resistant new construction per Minnesota code, as it's been for 11 or 12 years. It's a pretty sizable footprint, almost 1,900 square foot. I was lucky enough to work with a very conscientious builder on this. And every new home in Minnesota actually is required to have a blower door test. In this particular house, the blower door test, the air exchange rate is 1.05 ACH, which is tight. One of the tighter houses that this particular building performance company had tested. In Minnesota, the energy code requires you to be less than 3 ACH. It's got all your new construction components, gravel bed, drain tile, and a 3-inch passive riser in that drain tile. So here is the floor plan. And as found, I've got 4 diagnostic test holes, 1 in each corner, basically. On the top, there are window wells, egress window wells. Those window wells don't drain to anything to the interior. They just drain in the soil out around the house. These are the numbers I found when I got there. So this is just the passive system operating. And as you can see, I'm positive everywhere. So clearly the passive system isn't working right here. And all these numbers are in pascals. And it's full basement. There's nothing else attached to this. There's no crawl space or anything like that. So clearly we need to activate this. So we did. Started with the mid-range fan because that's commonly what I see in a lot of new construction, unfortunately, because of the misnomer that the low wattage fans have a higher failure rate. So we've got some companies that don't even carry the low wattage fans, unfortunately. And so this is kind of a build to show them, listen, you're probably overkilling these things. So with the mid-range fan, as you can see in the lower left where the sump, that's where the sump pit is. And that's also where the passive system is going through the floor. Our static is about 106. We're flowing at 65 CFM, which you would expect given the mid-range fan, and I'm pulling 52 watts. So what do you think the annual operating cost is of this system?
About $50.
50 bucks?
Plus whatever, $50 plus whatever air you're moving out of the house.
Sure. Okay, so let's make an assumption here that roughly 50 to 60% of the air is coming from the house. No matter how much sealing we can do, we're losing some air from the house. So plug it into our trusty little calculator here that Chad helped develop. Given the amount of airflow from the house, which is about 45 CFM, and for the Minneapolis heating days and cooling days, the furnace efficiency, the C rating of the AC unit, the cost of gas and electricity locally, the cost of added ventilation is $183 a year. Add on the wattage for the year, we're up to $236 for this homeowner to pay every year to run this radon fan. And if you go back, do we need that much? No, we don't. Not at all. We need like a tenth or less than that. So, all right, swap out to a low wattage fan. Low wattage fan still clearly kicking butt. We drop their flow, we drop their wattage. The operating cost for this one every year, assuming 20 CFM coming from the building, $82 plus 18 is $100 a year just to operate the low wattage radon fan. That's a much better palatable cost. Well, now we've got fans that are adjustable that can actually, well, they're low wattage, but they're even lower wattage. So I went in the attic and I dialed it down. I literally dialed it down till the point where it quit, and then turned the knob ever so slightly until it kicked back on. This is the pressure field I got. My static pressure is only 6.5 pascals.
Holy smokes.
I'm moving 8 CFM.
So for where I'm at, if we have 5 pascals negative everywhere, that's twice as much as what we need. In Minnesota, you need a little bit more because it's colder, more stack effect, but that's incredible. At 8 CFM, okay, you got to tell me what's the wattage.
What do you think?
I mean, you can almost see the impeller moving when it's at 8 CFM. 2 watts?
2 watts.
Holy smokes.
2 watts of power pulling this off. All because a conscientious builder sealed everything he possibly could. And I double checked it, 2 watts. Okay, what does that equate to? If half the air is coming from the house at 4 CFM, 2 watts is $2 a year. This is $18 a year.
Okay, so you just went from over 250 with a standard mid-range fan. Okay, there we go.
So additional attention to detail could go a heck of a long way here, folks. Mid-range fans, while they're great, they have their place. You know, I could fix 80% of homes in my state with a mid-range fan. I prefer the low wattage versions because of the annual operating costs that are associated with these things. And not only annual operating costs, but someone's going to be paying for these fans to be running for 10 or 15 years. So just by going from mid-range to low wattage, you're saving $1,300, $1,400 over 10 years. That is an opportunity for mitigators to sell that to their clients. The radon isn't going to be any better reduced for the mid-range fan from low wattage fan. So, you know, a little bit more attention to detail, a little bit more sealing and diagnostics up front saves a ton of money in the end.
That's pretty incredible. I remember somebody did a presentation about new construction and they built their own fan. And after that, I was like, we need that. We need a fan that's smaller than the smallest fan. And fortunately now we've got it. That's awesome.
Yep.
2 watts.
The only thing though, so going back to here, and we got to wrap it up. I understand everyone. How do we add a system alarm to something like this?
That's a good question, because what's your static pressure? 6.5 pascals, which is
yes,
less than 1/10 of an inch of water column. That's really low.
So it's like we need something that can measure that low and reliably, because I do think moving forward there's going to be a niche market for this for sure.
Or we need something that's looking at the impeller on the fan or the amperage on the fan or something like that.
Yeah, something different than what we currently have. Something in addition to what we currently have would be great. So there we go.
I think we're out.
Apart.
We can't hear you. You must be muted.
There you go, Don.
Better, sorry. The cat is on my lap at the moment, so she's being a little disruptive. So thank you guys so much. You did a great job as always. So we're gonna start moving things over to the 4 o'clock. But before we do, it looks like we have a few questions. And Nicole, if I miss any, please let me know. So I'm not sure. Let's see. Bob Lewis is asking, how can you have 140 CFM and 3.4 on your water column?
Yeah, I think I answered that in the chat, but the new adjustable fans can have that kind of capacity.
Okay. All right. Things are kind of all over the place Let me see. If we got it.
Josh asks, what types of soil are you running into?
Thank you, Nicole.
So for us, it's all clay soils. Josh, was that clay soils there at that house you were talking about?
No, that's new construction. It was gravel fill everywhere. So,
Well, it's gravel, but gravel on top of what?
oh, that's a good question. Typically,
It's got to be something pretty tight, right?
it is pretty tight. It's topsoil, virgin topsoil. I mean, this used to be all grassland, and then we cultivated and cut out forested grasslands. We cut it all down. We farmed it. We've been farming it for 400 years or whatever, but it's still there. You dig a hole and you're going to hit mostly dirt in this area where this house was built.
So Josh from the chat, as far as the geographic thing goes, yeah, absolutely. So in the middle of Kansas where I'm at, we have fairly consistently clay soils. Where Josh Kerber is there in Minnesota, they can go from clay soils to loamy soils to glacial moraine. Josh, what else? I mean, you've got the whole gambit.
Yeah, we do. And it kind of depends what area of the state you're in. We do have pockets of karst. We've got a lot of glacial till all over. If you look outside and you see a hill in Minnesota, it's full of big giant rocks, bigger than my head, believe it or not.
That is hard to believe. That's a huge rock.
Well, gentlemen, I want to thank you very much. This is the end of day 2.